In this video, we're going to take a look at some advanced factoring techniques. All of our factoring today is still going to come down to the 4 factoring methods that we learned yesterday. So that would be difference of squares, decomposition, factoring by grouping, and common factoring. So for the questions today, what we're going to notice, or what makes them advanced, is that we usually can factor more than once, and we're going to be looking at things that have higher exponents than what we're used to. So up first, we're going to talk about some differences of squares. So on your factoring flowchart, it says that a difference of squares has 2 terms that are being subtracted that are perfect squares. Now, a perfect square can be something to the power of 2, but it can also be any positive exponent. So, not positive, even numbered exponent. So it could be 2, 4, 6, 8, 10, as long as it's an exponent that divides by 2. So we're going to take a look at a question here. It says factor as fully as possible, and we have 81 cos to the power of 4x minus 10,000. So I do notice it has 2 terms. If I look to see if they have a common factor, 81 and 10,000 do not have anything in common other than a 1. And my cosine to the power of 4x, they don't both have one of those. So I cannot take out a common factor. Is this a difference of squares? Well, it has 2 terms. They are being subtracted. The exponent on my cosine is an even number. It's a power of 4. And then 81, I don't have my power sheet with me, but I can take the square root of 81. That works out to be 9. And I can take the square root of 10,000. That works out to be 100. So I am going to start with a difference of squares. The bottom of that was wet. That's weird. So this is going to be the square root of 81, which is 9. And then the square root of cosine to the 4x. So anytime I square root something, that square root is the same thing as doing a power of a half, right? We were doing that in our first unit. And then if I use my exponent laws and I multiply 4 and a half, 4 times a half is just 2. So when we are square rooting something with an exponent, we actually just end up dividing that exponent by 2. So here, this is going to be cosine squared x. We could have used variable replacement if you wanted to. And then the square root of 1,000 was 100. Sorry, 10,000 was 100. Now, difference of squares says one of the brackets is a plus, and then the other one looks exactly the same, but it has a minus. All right. From here, I'm going to look and see if I can factor them any further. So if I take a look at the first bracket, I do have 2 terms. They do not have a common factor. They are not being subtracted. So this is not a difference of squares. This is actually a sum of squares, and you cannot factor a sum of squares. So I cannot do anything with that first one. If I look at the second bracket, I have 2 terms. They do not have a common factor, but 9 is a perfect square. 100 is a perfect square, and that cosine squared x has an even numbered exponent. So I'm going to factor this one further. So we're going to leave the first bracket the same. So I have 9 cos squared x plus 100. And then my second bracket, we're going to do a difference of squares. So the square root of 9 is 3. The square root of cosine squared x is just cosine x. The square root of 100 is 10. And then we repeat those same things. One of them we're going to put plus, one of them we're going to put minus. And then I am just going to look again. So the first bracket didn't factor. Now I have 3 cos x plus 10. There are no exponents. So that is not a difference of squares, and they don't have a common factor. Same thing here, no squares. So that is as factored as this is going to be. Okay, we're going to take a look at our second example. This one is decomposition. So in grade 10, when we learned decomposition, we used it on quadratics that had x squared, x, and a number. But you can use decomposition as long as the first exponent on that x is double or 2 times our second exponent. So I do have an example here. I have 9x to the 4 minus 37x squared plus 4. So I notice that there are 3 terms, and then I notice 2 of them have x's and 1 of them does not, and that of the 2 that have x's, the exponent on the first one is double or 2 times the second one, right? 2 times 2 is 4. So that means I should still be able to do decomposition here. So when we do decomposition, we are trying to figure out what the 2 like terms were that we collected to get negative 37. And then the clue to help us out is that it should multiply to the same thing as the first and last term. So 9 times 4 is 36. So we're looking for 2 numbers that multiply to 36 and add to negative 37. So I always start by focusing on the multiplication number. So we're looking for things that multiply to 36. So you can use a multiplication grid to help you. You can use your calculator to try to help you. I'm going to go through and I'm going to start with 1. So on your calculator, you could do 36 divided by 1, which is 36. Can I combine a 1 and a 36 to get negative 37? The answer actually is yes, I can. So if I do negative 1 and negative 36, those would add together to give me negative 37. So my 2 numbers are negative 1 and negative 36. All right, so we're going to take those 2 numbers and we are going to replace the negative 37x squared with a negative 1, variable has to be the same, x squared, and a negative 36x squared. So this is 9x to the 4, and then it doesn't matter which one I put first. I think I'm going to put the 1 first, so I'm going to do minus 1x squared. It has to match the variable part there. And then minus 36x squared, and then plus 4. From here, we're going to group. We're going to group the first 2 terms and the last 2 terms and take out whatever they have in common. So from my first 2 terms, the 9 and the 1 don't have anything in common, but they do both have an x, lowest exponent 2. So I'm going to take out x squared. So 9x to the 4 divided by x squared. I'd have to multiply x squared by 9, and then 2 more x's, so that would be x squared to get 9x to the 4. And then to turn an x squared into a minus 1x squared, I would need to multiply by minus 1. We always take our sign from the middle, so this is going to be minus. And then I'm going to look at the 36x squared and the 4. So 36 and 4 both divide by 2 and 4. So we want to go as big as possible. So we're going to take out a 4, and it's going to be a negative 4. So what would I need to multiply negative 4 by to get negative 36x squared? Well, that would be a 9, and then it needs an x squared. What would I multiply negative 4 by to get positive 4? Well, the sign changed, so negative 1. Okay. From here, I do notice these brackets are the same, which is good. If they weren't, we did something wrong. So I have a common factor of 9x squared minus 1. And then we are multiplying by x squared to get that first term, and minus 4 to get that second term. Now, anytime we have an exponent that's bigger than a 2, there's a really good chance we might be able to factor again. So we're going to see if we can factor that further. So I notice 9x squared minus 1 has 2 terms. Do they have a common factor? No. Are they a difference of squares? Yes. They have 2 terms, they're being subtracted, and they're all perfect squares. So I'm going to square root the first one. Square root of 9 is 3. Square root of x squared is x. I'm going to square root the second number. That's just a 1. And then we're going to add in one bracket and then subtract in the other. All right, I'm now going to look at the x squared minus 4. This also has two terms. It does not have a common factor, right? But it does have two terms that are being subtracted, and they are perfect squares. So this is also a difference of squares. So I'm going to square root the x squared to get x, square root 4 to get 2. I'm going to add in one bracket and subtract in the other. If you wanted to subtract first and then add, that is also okay. So looking at my remaining brackets, there is nothing else that I can do with those. So my final answer is 3x plus 1 times 3x minus 1 times x plus 2 times x minus 2. All right, I'll see you in the next video.